As a general statement, winter tires negatively impact the range of an EV. The rolling resistance of winter tires is generally higher than what a good summer tire is expected to have due to multiple reasons, but the most important are the tread design and the rubber compound properties. Winter tires have a tread design and pattern specifically designed to offer grip when rolling on snow, slush and water-covered road surfaces, while the rubber material was tuned for flexibility even at low temperatures. This leads to higher rolling resistance, which leads to more energy being used by the vehicle to drive from point A to point B. But how big will the range drop be? I have devised a simple test that would help me estimate this. So keep watching and get all the details, or skip to the end to see the results. To do that, you can use the chapters from the play bar or the video description. For this test, I will be driving a Tesla Model 3 rear-wheel drive equipped with the 60 kWh LFP battery and fitted with the standard 18-inch wheels with aero covers. The run consists of high-speed driving at a cruise speed of 130 km per hour with an average speed exceeding 120 km per hour. The test track I will be using is nothing more than a 15 km highway section that I will be driving on forth and back for a total distance of about 30 kilometers. I will be performing two test runs. The first run using the summer tires and the second run using the winter tires. By now you might be wondering which tire brand and model will I be using. The Michelin Pilot Sport 4, the tires that were fitted to the Model 3 from the factory, are the summer tires I will be using. The winter tires I have chosen are the Continental Winter Contact TS 870P. These are excellent winter tires with especially low rolling resistance for a winter tire. However, I chose a slightly wider tire, 245mm instead of 235mm. I did this for some extra ride comfort. This will have a slight influence on the consumption results. So two premium tires from highly regarded tire manufacturers. One more thing, for consistency between the two runs, I will be running the test without cabin heating. Also, the battery will be conditioned before each test so that there is no risk the car will decide by its own to draw energy for battery heating. So let's get on with the test. First test with the summer tires. Getting up to speed. Resetting the trip meter and running the tests. So as we get to 30 kilometers in 14 minutes, the average energy consumption is 166 watt hours per kilometer or 16.6 kilowatt hours per 100 kilometers. Second test now with winter tires. Okay, so starting the test. I'm already on the highway, accelerating to 130 kilometers per hour, setting the speed on the adaptive cruise control, and then trying to keep this speed for as much as possible, for as long as possible. As I said before, I'm doing the test without cabin heating. I am now resetting the trip meter. Yeah, and now I will be doing the tests. Okay, so I'm almost done with this run. I'm approaching roughly 30 kilometers. Did that in 14 minutes with an average energy consumption of 176 watt hour per kilometers or 17.6 kilowatt hours per 100 kilometers. So the results are in, but before I show them to you, let me do a very short summary. What I did here was a simple test meant to evaluate the drop in efficiency that you get by switching from summer to winter tires. 2 tests were run, each 30 kilometers long, with a cruise speed of about 130 kilometers per hour, resulting in an average speed higher than 120 kilometers per hour. The first one with 235mm wide summer tires, followed by a second one with a brand new set of 245mm wide winter tires. The ambient temperature during the 2 speed runs was between 7 degrees Celsius and 14 degrees Celsius. The battery was conditioned before each test run and no cabin heating was used. Now finally the test results. The average energy consumption during the test with the summer tires was 16.5 kilowatt hours per 100 kilometers or 165 watt hours per kilometer. Running the same test but with the winter tires resulted in an average energy consumption of 17.4 kilowatt hours per 100 kilometers or 174 watt hours per kilometer. So running the test with the winter tires resulted in a 0.9 kilowatt hour per 100 kilometers higher average energy consumption. This means that driving with the winter tires will result in a 5.5% range reduction. So I was hoping for a smaller difference between the two. But at least the winter tires are much quieter than the summer tires.